Well, this is Dr. Ansar Ahmed sign in, and in this episode, I'm going to cover fifth generation of cellular system and how this is different from fourth generation. So, for next few minutes, come with me. It is quite interesting to know that in every 10 years, a mobile generation is born. In 1980, in which we had first generation of cellular system, which was based on analog technology only for voice communication. In 1990, we got second generation, which came with digital technology and for data transmission as well. In 2000, we got third generation, which was introduced with the concept of multimedia on phone, and in 2010 we had fourth generation of cellular system, which was introduced for IP network on phone, and thus it is hijacking or dominating our daily life, as we have seen in many sci-fi movies and book stories. 5G is the fifth generation of cellular technology, which is born somewhere in 2019, that will be succeeding the current 4G LTE technology. 5G is bringing new capabilities that will create opportunities for public, business and society. By 2024, experts forecast that there will be around 1.9 billion 5G subscribers worldwide. Developed Asia and North America are expected to grab the 5G technology faster than the other region. What is special about 5G and how it is different from the rest of its four previous generations? It is claimed by experts that 5G will provide 1000 times capacity than 4G in terms of users. The things do not end here. It is also claimed that 5G will be 100 times faster than 4G. So for keeping all its promises and for its wide services, 5G network operate on up to 3 frequency bands: low, medium and high. 5G network will be composed of network of up to 3 different type of cells, each requiring a specific antenna design, each providing a different rate of download speed versus distance and service area. So 5G has 3 frequency band: low, medium and high. In low band, 5G uses one similar frequency range as 4G cell phone, starting from 600 to 850 MHz, giving download speed a little higher than 4G, which is 330 to 250 megabit per second. Low band cell towers have a range and coverage area similar to 4G towers. In mid band, 5G uses microwave of 2.5 to 3.7 GHz, allowing speed of 100 to 900 megabit per second, with each cell tower providing service up to several miles in radius. This level of service is the most widely deployed and should be available in most metro areas. Some regions are not implementing low band frequency, making this is the minimum service level. And the last band which will be used by 5G will be high band. 5G uses frequency of 25 to 39 GHz near the bottom of the millimeter wave band. It often achieves download speed in the gigabit per second range, comparable to cable internet. However, millimeter waves have a more limited range, requiring many small cells. They have trouble passing through some types of material such as walls and windows. Due to their higher cost, plants are deployed these cells only in dense urban environment and areas where crowds of people come together, such as sports stadium and convention center. The above speeds are those achieved in actual tests in 2020, and speeds are expected to increase during rollout. The next biggest feature of 5G is massive MIMO, multiple input, multiple output. Massive MIMO is a key enabler of 5G. Extremely fast data rates and promise to raise 5G's potential to a new level. Massive MIMO, which is extension of MIMO system and which is part of 4G technology also, by adding a much higher number of antennas or transmitter and receiver. The massive number of antennas help focus energy, which brings drastic improvements in the throughput and efficiency. Multiple antennas use the spatial dimension in addition to the time and frequency ones without changing the bandwidth requirement of the system. Each antenna is individually controlled and may embed radio transceiver component. How messy MIMO improves throughput and efficiency. Not like throwing waves in all directions, MIMO makes beamforming, which is used to direct radio waves to a target. This is achieved by shaping the radio waves to a point in a specific direction. The MIMO technique combines the power from elements of the antenna's arrays in such a way that signals at particular angles experience consecutive interference, while other signals pointing to other angles experience destructive interference. This improves signal quality in the specific direction as well as data transfer speed. Now let's move on next technology of 5G, which is use of a small cell. A cell is the geographic unit that is covered by a single base station in a cellular network. 5G is based on a small cell concept, which are low-powered cellular radio access nodes that are operate in licensed and unlicensed spectrum that covers a range of 10 meters to a few kilometers. Small cells are used in 5G network as 5G radio waves cannot travel longer distances because of high frequencies. Although the use of high frequencies is important to have more bandwidth, but it is equally true that use of high frequency band making 5G more controversial and stopping 5G deployment in many countries across the world, because it is supposed that high frequencies radiate high radiation, which is dangerous to human and animals' health. Well, not going into this controversy, let's move on next technology, which is making 5G super fast, is edge computing. Edge computing is delivered by computing server closer to the ultimate users, which reduce latency and data traffic congestion. 4G provides latency around 20 to 30 milliseconds, and in 5G it would be only 1 millisecond. The last technology of 5G is channel coding. Channel coding, as you know, is a process of detecting and correcting bit errors in digital communication system. Channel coding is performed both at the transmitter and the receiver. At the transmit side, this is referred as the encoder, where extra bits are added with the raw data before modulation. At the receiver side, these bits are extracted, and this is called decoder process. Channel coding enables the receiver to detect and correct error if they occur during transmission due to noise, interference, and fading. The channel coding techniques for 5G have changed from turbo codes in 4G to polar codes for the control channels and LDPC, low density parity check codes for the data channel. So guys, it was all about the 5th generation and its hype. This was all about 5th generation. How you did like the lecture and what points you did not like, or what you want to know, please let you comment in inbox. And if you like the lecture, please subscribe my channel, share it and like it. Sign out, Dr. Ansar Ahmed. Bye and see you again.